This week, Mike Cohen from Rapid7 and Wes Lambert from Security Onion Solutions join us for a segment on Velociraptor, digging deeper. Then we attempt to confirm or deny that Enzyme performs intelligent device fingerprinting and behavioral analytics to detect rogue actors. In the security news, what to do with your old hardware, renting your phone, persistently execute system software in the context of Windows, sensational headline, ransomware could cause a food shortage. Could someone please schedule the year of the Linux desktop? Public key crypto explained or not? Malware attacks from Windows through Linux. Microsoft Exchange auto discover bug leaks 100,000 credentials. And toilets that can identify you from, well, the bottom. All that and more on this episode of Paul's Security Weekly. This is Security Weekly. For security professionals, by security professionals. Broadcasting live from G-Unit Studios in Rhode Island, it's the show where exploits run wild, packets aren't the only things getting sniffed, and the cocktails flow steady. It's Paul's Security Weekly. Keeping up with security issues across thousands of web assets without the right approach to web application security is a daunting task. Get ahead with web vulnerability scanning automation from NetSparker, a leader in dynamic and interactive application security testing, known for its ease of use and accurate results. Detect a wide range of vulnerabilities in all legacy and modern web applications, address security bugs at scale by automating the confirmation process, automatically prioritize vulnerabilities, and assign actionable tickets to the right developers in their native workflows for rapid remediation. For more information on how to scale application security with ease, visit securityweekly.com/NetSparker.
And welcome to the show. But first, let me introduce you to a man who got his enzymes all over the place this week, Mr. Paul Asadorian.
Welcome, everyone, to Paul's Security Weekly. It's episode number 711, recorded on September 23rd, 2021, right here in G-Unit Studios in Rhode Island. That's right, I am rocking the sport coat with the t-shirt to basically troll Chris Cochran from the Hacker Valley studio, because he's not the only podcast host that can rock the sport coat and the t-shirt.
I mean,
little trolling going on. Mr. Doug White is here.
It left me speechless to see you in a white sport coat and a pink crustacean or something like that.
No, I'm not Don Johnson on the set of Miami Vice now.
Where's Tubbs?
Hey, I'm over here.
He's in the evidence locker with the drugs.
Eyes up here. No, it's a great look. I mean, I'm very impressed.
My wife actually complimented me.
It's giving the show an air of respectability it doesn't deserve.
Yeah. Wait until we get through these martinis and some bourbon.
Well, yeah, and get the hammers out and start banging on the computer case. Like, I'll straighten that out.
If you haven't checked out Doug and I's video on building a computer, it's absolutely hilarious. There's multiple hammers involved.
Oh, yeah. It starts off with hammers.
In fact, one of our friends on Facebook was posting that her case had come damaged. And I'm like, we got you. We got you, my friend. I'm like,
how-to video.
Yeah, how-to video on how to. Except her case was all. I realized it was all glass.
But like you said, you got it, Lady Nikon. You're all squared away. They'll fix you up.
That's it. What's going on, Larry? Larry's here remotely. Larry's remote this week.
Yep. Yeah, no, doing a bit of teaching this week, so the schedule just didn't work out for me to make it to the studio. So here I am.
Good to have you, Larry. Mr. Tyler Robinson is here with us as well.
Buenos dias. Good to be back.
Nice to have you back, Tyler. You were on a little trip. I won't say anything else, but you were on a little trip, and you're back from the little trip, and now I'm glad to have you back on the show. It's nice.
Thanks, buddy.
Mr. Lee Neely is here with us. Lee, welcome.
Hi, it's good to be back as well. Had a little fun up in Alaska. Now back in the lower 48. A little bit warmer.
I live vicariously through you, Lee.
Yeah, we all do.
In your travels. It was Hawaii, then Alaska. It's good to have you back as well.
As long as you don't live Viagra-ously through him.
That's a completely different thing. InfoSec World 2021 is proud to announce its keynote lineup for this year's event. Here from Robert Herjavec, plus heads of security at NFL, TikTok, U.S. Department of Homeland Security, Stanford University, and more. Security Weekly listeners save 20% on the Digital Pass registration, as this is now an all-virtual event being held from November 9th through the 10th. You can visit securityweekly.com/ISW 2021 to register today. Joining us for this segment is Mike Cohen and Wes Lambert. Mike is a digital forensic researcher and founder of the Velociraptor project, and Wes is a principal engineer at Security Onion Solutions. They join us tonight to discuss Velociraptor. Welcome, Wes and Mike.
Hi.
Hello, and thank you. Hey, how's everybody doing tonight?
Doing great. I'll choose one of you at random. Wes, I want to, before we kind of dig into it, get to know you a little bit by asking you how you got your start in information security.
Sure. So, a while back, probably, let's see, was that
the 80s? No, not that far back.
No, not the 80s. Look at me. I'm like, no. So I actually got my start, I was doing some system engineering stuff around identity and access management. So I kind of just started in a form for the most part of information security, maybe not as common as the one, the disciplines we all think of. Although it is a little bit more common today. You see IAM a lot more today, but kind of got my start in doing some kind of generic system engineering and IAM, and going from there and kind of going into the broad, every domain of InfoSec. And then recently, until about, I guess, 4 years back now. So it's been a little over 4 years. I've been with Security Onion Solutions, focusing on enterprise security monitoring. So things like network security monitoring and host-based monitoring, things like that. So that's kind of how I got in, and very briefly where I got today.
Fantastic. Mike, how'd you get your start in information security?
Oh, that shows my age, I guess. I've been in information security for well over 20 years. And, I was working for the federal police and doing digital forensics. And, I've been in digital forensics first and then moved into enterprise DFIR later on. I joined Google in 2010 and worked with some, very excellent people and did some really cool stuff. And in 2018, I founded Velociraptor, which is an endpoint visibility tool or framework. And I joined Rapid7 this year to continue working on Velociraptor. So it's been a real fun ride so far.
Yeah, Mike, where are you from? I can't for the life of me pinpoint your accent.
Oh, I've lived all over the world. I was in Europe for many years with Google and in Seattle, and I've lived in the US. But currently I'm in Australia. Okay. I'm on the Gold Coast, which is, as you can see in my background, is a very sunny place. So yeah.
Yeah, I would have guessed Australian, but someone who traveled around a lot, right?
Yeah.
No, that's awesome. I guess my first question for either of you, right, is when we talk about Velociraptor in doing endpoint forensics, how is that different? Because we were just saying before the show, I've been playing around with things like OS Query and how'd you say it, Wes? It was Waza or Wazoo?
Wazoo.
Wazoo.
Yep.
I like Wazoo better. It sounds better. And some of the log beats and things like that. So how does Velociraptor different from some of those other open source offerings that can give you some of that telemetry from your endpoints and hosts?
So the idea with Velociraptor is to move a lot of the forensic analysis that we typically do to the endpoint. So if you look at the standard, gold standard sort of in the industry today for, monitoring or log analysis or whatever, it would be you just kind of like hoover down all these event logs from the endpoint and then just shove them into a big backend like Elastic or Splunk or something like that, and then do these data mining kind of queries on it and try and figure out what's going on. And that's a good approach, but it doesn't really scale very easily. And the more machines that you're monitoring, the more you have to throw resources at the back end, because naturally everything is concentrated at the back end. And if you're just hoovering up all the evidence from the endpoint and you're shoving it all into one place, then that one place has to scale with the number of endpoints that you have. So the approach with Velociraptor is to move a lot of that analysis to the endpoint. So we're doing those queries on the endpoint itself. And by doing that, we can actually only surface high-level or high-valued events that we are sending, to the server. So we actually reduce all our complexity and make it much more scalable. And so, I guess, for the Velociraptor project, we've had a couple of good inspirations because, as you said, there are many very good open source tools out there. And OSQuery was certainly a wonderful inspiration for us. Because I think OSQuery was like the first tool that it actually proved the concept of, I'm going to make this query language where I'm going to push that query out to the endpoint, and then I'm going to be able to do that analysis or that filtering straight on the endpoint and just get back the information that I need, right? And I think that was really revolutionary, and it was an inspiration for us. So with Velociraptor, we just went, well, look, we think the query language is really kind of the future. It's really the way forward. So let's take that idea that OSQuery had with the SQL query, and we identified that SQL was just not a flexible, powerful enough language to actually go beyond, the capabilities of OSQuery. So we come up with a whole other query language, which is specifically designed to gain access to low-level forensic analysis type, information, and then just put that on the endpoint and develop that query language to the point where it can really do, a lot of very cool stuff, which goes above and beyond anything that's been done before, right? So certainly, it's kind of like you could think of it as like OSQuery, the next step, kind of,
It's interesting. Like sometimes people, I've been asked in the past, like, tell me an interesting story. And Doug's a bad example because he probably could. But most of us normal human beings, like we kind of freeze. Like, wait, of all the interesting stories that I have, and I've told a lot of really funny stories in the past, when you just get asked that one question, like, tell me an interesting story with no context, you tend to freeze. And that's kind of how I feel like, OSQuery and some of these other systems that you can ask it any question you want. And when I'm presented with the console, I'm like, this is great. And I'm like, wait. What am I going to ask it? So where do we start, Mike and Wes, in helping people, kind of guide them and give them some context on like what questions do you want to ask, and then maybe building on top of those.
Yeah, exactly. This is a really, really important point. With a lot of the OSQuery, like OSQuery is nice, and and Velociraptor is also the same thing. You can ask any query you want, right? But from a usability perspective, if you have to sit there and type an SQL query or VQL query to query the endpoint, there's kind of like so much that you can do, and it would just not be a great user experience as well. And you wouldn't remember what you're supposed to be typing as well. So, like you end up with a lot of people, that use OSQuery and they have the little spreadsheet with, their queries, and they just like copy and paste, their query into the console or whatever, right? So what we decided to do in Velociraptor is go beyond that. So the query engine is the engine that makes it go, right? But it's not a great user interface, and we don't really want people to use that all the time as the first thing that you do, right? So what we have is a concept called an artifact. And an artifact is a YAML file, which just basically like encapsulates the query. So it has the query in the YAML file, but then it has a name and a description and some parameters that you can use to manipulate the query. Now, we're going to see that a little bit later in the demo, but it's basically designed to be user consumable. So the query side of it makes it really easy to customize and then basically implement whatever kind of security checks that you want. But then what is actually being consumed by the end user is that artifact, which is just available through the UI, and you just basically click on the artifact and run it, right? So we've got context, we've got parameters, and then we have some post-processing and reporting and all this sort of stuff, and that basically gets packaged in this YAML file. So most people don't really need to use VQL to actually use the product. You can just select what artifact they want, collect what they want, and go from there. Right.
Yeah, that's nice, because I think there's a lot of us listening. They're like, wait, I got to learn another query language because there's so many of them today.
Right.
Sorry, Wes, were you going to say something?
No. I think I was just going to add on there, kind of as Mike was saying, just encapsulating that expert knowledge, right? You don't have to be an expert DFIR practitioner to be able to use Velociraptor and get really good results.
Wes, my question for you is: is it integrated with Security Onion, and how so?
Sure. So it is not currently integrated. I have been kind of doing some work on the side to integrate it myself and maintain that integration. And part of that was really to get, or really to bring Security Onion kind of full circle with that collection, detection, and response, right? So I think it adds, a complete other capability. While OS Query and Wazoo, they do have their capabilities and the ability to query and whatnot, but this really takes it to a whole nother level where you can use the platform along with Velociraptor to do almost everything you need to do in your enterprise security monitoring and response phase, right? So
how does Velociraptor help with the response phase?
Sure. So, if you want to gather additional info from hosts, right, you're investigating something and maybe you're already collecting Windows logs, or maybe you're not, and you have this IP address with this host name, and you want to look further into that, you can use Velociraptor to go and dig further. You can gather host-based artifacts like processes in memory and MFT and USN journal. I mean, there's just it's the list goes on and on. But basically, you're able to do all of that remotely. You're able to see the results back in Security Onion and then correlate that activity and be able to kind of go from there. It's just gathering a lot more context and coming to a conclusion a lot more quickly.
Mm. Yeah.
How is that gathering data?
Also, this might be a slightly different approach, I guess. Like a lot of the other tools, OS Query, for instance, as a design philosophy is it's a read-only system, right? So a lot of tools go to extremes to prevent modifying the system, which is a good design goal, right? What we sort of did with Velociraptor is we basically realized that in order to respond to an incident, so that's the R in DFIR, well, you're going to need to modify the system, right? So we actually do allow modifying the system, with the controls and all this sort of stuff, right? So, for instance, if you have scheduled tasks that are, added by malware, then you want to actually be able to remediate that by removing them or modifying the system. So we do actually allow that, with, suitable controls. And so we can use Velociraptor to do remediation, and, we can discuss, how, risky that is depending on, the situation and how well tested it is and so on. But it is possible to do remediation at scale, right? So, if you have a big, crypto miner infestation or something like that, then you can easily, do a hunt in 2 minutes. You can clean up, 2,000 machines kind of thing, right?
Sorry, Tyler had a question.
No, yeah, I was kind of curious. How does the agent interact? I'm assuming it's an agent on each of the endpoint devices to be able to interact with that. Is it doing API calls or using WMI at a low level? What's the communication and the protocol look like? And then if it is doing that, how is there any data correlation where you're sending that back to like a data lake or to a SIM integration so that you can query past and present, or is that all real time and kind of live?
So all of this is possible, right? Every single thing that you've said is possible because ultimately Velociraptor is just a query engine. So that's all it is, right? It just runs your queries, and whatever queries you choose to run, that's what it's going to do, right? So the query language provides the ability to do all those things that you mentioned, like WMI calls and API calls and other things, and even forensic analysis, looking at MFTs, looking at NTFS artifacts. All of these things are possible. We're looking at ETW and forwarding events. All of these things are accessible through queries, through VQL queries. And then depending on what query you want to run, then you just get your data. So you think of it as Velociraptor is kind of like the collection tool. And a lot of people take that data and then they feed it into, something like Elastic or Splunk or another SIEM. And then to get that, historical context, if they want, A lot of people just collect the data and keep it as, big JSON files in S3 storage, so they can, go back and grab if they needed to. But, unless they actually need to query it, in a live database, there's no need to keep historical data for very long. So these are all possible. This is what makes the tool so exciting, is that it's so flexible, and the way that it's used is really kind of up to the user, right?
So my question with the endpoint processing is, how do we not DOS our endpoints? I mean,
that's an excellent question.
They're already mad at us for all the cyber stuff on the endpoint.
Yeah, excellent. So this is a very, very important question, and we need to make sure that our impact on the endpoint is very controlled. So when, depending on what you're doing, you might require a high CPU use, because let's say there is a very critical thing that you need to do, and you don't care, and then you need to do that. So to help you understand what the endpoint is doing, then we have a lot of tools, mechanisms in process. So the first mechanism is that we can collect telemetry every 10 seconds, like how much CPU are we using, how much memory are we using. This is happening automatically all the time, right? So you can go back historically and say, okay, on Tuesday at this time, the user complained that we were doing something, and here it is, that's how much CPU and resources we used. So we've got that constantly happening. And then one of the other really important differences between Velociraptor and OS Query, for instance, is that Velociraptor is asynchronous and cancelable. So that means if I do a query and it turns out that it just doesn't work out, like it's consuming way too many resources, and it just I don't want to run it anymore, right? Like, so when I hit cancel, it immediately cancels that query, right? So it's immediately cancelable and controlled, right? So I don't have to. So unlike, because it's asynchronous, right? So unlike OS Query, where it's kind of like you fire and forget, and then if you get something back, then with OS Query, we have like the nanny, and it checks that it checks that it's not using too many resources. Then it kills the thing if it does, and we actually have a cancelable. The VQL is cancelable, so we can cancel at any time. So that means that we can put resource limits on how much CPU it's going to use, how much memory it's going to use, and how long it runs for. So like by default, when you're running a query, it's 10 minutes. So like you're going to run this Yarrow scan for 10 minutes, and if it takes longer than 10 minutes, it will just cancel and stop, right? Because and then we'll have to go back and rethink our do we really want to run it for longer, or sometimes we do, so we can increase that. Sometimes we don't, right? Because this is like a nature of the FIR, because you're running on systems that you really don't know. So like a lot of the time we think that what we're doing is light, like we're going to just search through this internet history, where it turns out that this is a terminal services machine, and it has 200 users with like terabyte of internet history, right? You just don't know that in advance. So until you do it. So you need to have these kind of safeties built in, so that you can, catch these problems and stop, right?
Well, yeah. being a mainframer from way back, I always have a lot of trust issues with endpoints. And since you're not bringing everything back to a central place, how do you protect against data loss out there on those endpoints if something happens to them? So you want to collect that data and something has happened to the endpoint. Can you, is it just gone, or how do you get that information?
So it depends so when you say collect the data, right? In DFIR, like data that's 2 days old is not relevant, right? We just don't care about it. Mm-hmm. Like if you want to look at the process listing and it's 2 days old, mm-hmm. Unless you are owned at that time, then, going back to it is not really helpful. So a lot of the data that we collect that, just in case, is not that useful as we would like, right? So what I like to think of it as basically saying, well, the endpoint is the ultimate source of truth, right? And so when we have the ability to query the endpoint, it's like having a distributed database, and you're just saying, hey, tell me what's the state right now, right? So you're basically querying the state of the system, right now. And the historical thing is less useful because, if I want to know what processes are running, well, the processes that ran last week, are not that relevant because I can't really pivot into them and look at them more. And, I want to be able to do that.
Well, I guess I was thinking more like, I was thinking more like, okay, 2 minutes ago, that endpoint ceased to exist. I don't see it anymore. I can't query it. Right. Is that data encapsulated somehow so I can go back to that endpoint and say, what happened? Why did you cease to exist? I mean, is that protected somehow there?
Well, I mean, the data that's been collected so far, of course, is still stored on the server, right? So you can still collect data, right? So it's not just, for example, like I can run a hunt and collect prefetch data for all machines, at a certain point in time. It's kind of like, so we are capturing the data, right?
Okay.
On the server. So it doesn't, cease to exist. We can go back to look at it. But, if the machine fell off the network and you don't know why, I mean, that's still not going to help you, right? Because you still don't know why, right? It could have just been stolen or unplugged or whatever.
Yeah, I guess I was thinking the data. I was thinking the data was sitting on the endpoint, not on the server.
No. I mean, we still collect stuff, right? We collect all the data to the server and we push it up, right? But what we're looking for is, so for instance, like let's say that we're looking for certain detections, that we're looking for example, malicious processes running or registry keys changing or whatever, right? Mm-hmm. So I guess my point earlier was about traditional sysmon style monitoring, where you're just basically forwarding all registry changes and all process things, and then on the server you're saying, oh, did this key change? Because that indicates something, right? Well, that's not scalable because I have to forward every single registry change and then do this querying on the server, right? Whereas the Velociraptor approach is to just go, did this key change? So you just immediately ask for it on the endpoint to say when it's changed, and that changes the response because it means that the endpoint knows immediately when the key changed, right? So if you're watching a particular key and you're saying, I want to know whether it changed, then you can tell immediately that it happened, right? Because you have this query running, then it basically does this checking on the endpoint. And then you can, in the query itself, you can say, well, do something about it, right? If this happens, then do something about it. So the response is kind of built into the query because, again, VQL can actually respond because it can change the state of the system. So you can write, queries that do things that can take action when something happens, rather than, the current state of affairs where you're just kind of like forwarding all the events to the endpoint, to the backend, and then doing some Splunk queries. And then at some point you detect there is some problem, and then you try and go back and escalate to do this remediation. But, there is this kind of like long loop, this OODA loop, right, where we are going back to identify the issue and then coming back to the endpoint and trying to correct it. Well, you could actually program all of that into the query so that it automatically does it. So, if it detects, PSExec running, then immediately it alerts, but it may also, shut down the servers or whatever, like these kind of things, right?
I remember the days when doing forensics was I had to physically go somewhere and run things like TCP view and all these other tools, right? Forensics tools on the systems to determine if they were compromised. And I remember being at the university, and sometimes I had to go into like really strange places. Universities have strange places. Like I had to put on booties over my shoes and walk through doors that had like, danger, biohazard, radioactive waste. And I'm like, whoa, wait, I'm not going in there. And they're like, oh no, we just put that sign there so people don't bug us. It was very strange. This sounds like a way that I can do all that remotely, basically, right? Do all those forensics to determine if this machine has become compromised and even take some action, right?
Yeah, absolutely. And like a lot of the work that we do are for things that are really inaccessible. So we've had some clients that are, like mining companies that work in some really remote areas. And they might say, hey, this box comes up, once to check their email, like every 2 days, because they just have no reception. They are like out there somewhere, really remote. So this is actually also another aspect is that some of the other tools, you can only really talk to the machine when it's on the network, right? So it's kind of like a live thing, right? But with Velociraptor, what we do is when you're doing collecting an artifact or collecting some queries, is that you're scheduling them. And so when the machine is offline, it just kind of like sits there. The server says, okay, when it comes back online, I'll schedule that. And so when it comes back online, it will just run the query, collect the results, and then you'll be able to see it again. So I don't have to kind of like time zone chase this machine that, just comes up 10 minutes every two days, right? So
it's open source. So does that mean I can get it and use it at school?
Yeah, absolutely.
Oh, okay. I like to ask that question.
It's totally open source, and it's on GitHub, and we have a community on Discord as well. Jump on and have a chat with us. And if you have ideas, questions, we are always there.
That's cool. I mean, it sounds like a really interesting product, because I was in a meeting earlier today where people were asking those very kind of questions about how do I collect this, what are the options and things like that. So it's very interesting to see that there's something like that. I like the way it sounds.
You're going to get to see it though, right?
Yeah, they're going to show it to us.
Yeah,
you want to see it.
I could show you. Yeah, let me just turn on the screen share and let's see. Let me know if you can see it.
Yes.
Okay, cool. So this is kind of like the main screen. As you can see, it's actually really easy to set it up. We normally run it in the cloud. You can also run it on site as well. But it takes like 5 minutes to set up. It's really quick. This is a test machine that I have. This is kind of the main screen that you'll see.
You're telling me that an open source security tool takes 5 minutes to set up?
Yeah, there's some videos on YouTube if you want to take a look. Yeah, it
takes like 30 seconds.
5 minutes to set it up. Yeah,
that's good.
Really quick.
I joke there because a huge part of my job today is actually installing, configuring, and using open source tools as part of our lab's product reviews. And I can tell you, sometimes it takes more than 5 minutes. I'm just saying.
So one of the things in Velociraptor is we try to reduce the number of dependencies. So there are no dependencies. There's 0 dependencies. So it's basically a binary. You download it from GitHub. And then, we could just go GitHub, Velociraptor, and you just go down here, you grab your binary, and it's not even a package. It is really just the executable for the different platforms. There is an MSI if you wanted. And then you basically just run it. So it doesn't have any, it doesn't really use a database. So it uses files as the backend. So there's no database to set up. There's no, it just works. So you just run it, set it up, and off you go.
Hey, Mike, what's it written in?
It's in Go.
Sweet.
Golang. Yeah. So if we have a look, this is the documentation site, and you can have a look at the deployment guide here. And these are the different options for deployment. But your typical deployment is you can actually just run it like this as well if you just want a demo. Just play around with it. That sets up a local instance, but you basically just go through there, and there it is. There's your server, right? So yeah, this is build a Debian package and install it. So it's actually really quick to deploy. Once it's deployed, I have a test machine here, and you'll get this kind of like welcome screen. And if I have a look at this, just shows me all the clients. And you can see that, I've got on this machine, I've got about 200 clients set up just for testing. You see that are just like -1, -2, and so on. Or you look at your recent hosts, that are ones that I've been working with before. So let me just pick this one up. You can actually just get access to the file system directly. So, here I am just kind of browsing the file system. So this is actually looking at the file system from that the server knows. So I can actually just kind of browse the directories. And if I click on this, that refreshes that view. So it goes out to the endpoint and looks at the files. So a lot of people use that as kind of the first sort of familiar interface into Velociraptor, where, I can just kind of like look at, like update that and refresh that. Can do like a recursive refresh and so on. Look at all the different files and so on. But I just wanted to show you guys what when I click on the interface here, that just kind of like runs queries in the backend so everything is in VQL in Velociraptor. So I can run queries in the backend to actually look at the host. if I have a look at this, this is the host overview screen. So it just shows me a little bit about the host. If I click on this, I can quarantine that host. So sometimes when you're doing the FIR, you might get an alert and you just want to investigate this, but you want to make sure that that machine can't contact outside while you're doing this investigation. So we can quarantine the host, and that basically locks it so that it can only talk with the Velociraptor server. So you can still continue on doing your analysis, but the user, can get a message to say, hey, this machine is quarantined because we're looking at it. So this is kind of a nice, easy way to just kind of like time out a machine, right? Up here, I can see it's connected. So Velociraptor doesn't really, it can fall back into polling mode, but normally it's always connected. That means that when I issue a command, it just does it. Like it doesn't need, in a lot of other systems, you issue a command and you have to wait for it to pull back and receive it. So it's actually very, very quick. And we can run shell commands like PowerShell, like even dir C. And then, when I launch that, so this is like the interactive shell command, but we prefer generally not to, there's the results, not to use that because we want to have more structured queryings. But let me just show you this side screen here, collected artifacts. So when I was, typing things, interacting with the UI there, what was actually happening is that behind the scenes, Velociraptor was collecting artifacts from the endpoint, and you can see this is what was happening. If you recall, I did a dir command, and it was collecting this system PowerShell artifact. So this is an artifact that allows you to run PowerShell commands, right? So you can get that data. So this is how we actually interact with the endpoint. We can list the directories, we can run a PS list, PowerShell, all this sort of stuff. And these artifacts, this is the artifact. If I click on this, I can see the details of the artifacts. This is a very simple one. This is the VQL that is run. Let me just pick, maybe one of the other ones. Each artifact has VQL. So this goes back to the thing that we talked about before, where you have a really powerful query language, but your user doesn't really need to know that. They just need to select the right artifacts to collect. So for instance, in this case, let's suppose that I wanted to collect scheduled tasks. So I'm just going to click, that plus icon there to create a new collection. Then I'm going to search for the right artifact that collects my scheduled tasks. So I'm going to collect these scheduled tasks. Here I get to see, what is the query in case I want to know, but I don't have to. I have a bit of a description here so I can tell what is this thing going to give me, right? This is going to be useful for me. And I can also control the artifact by having some parameters. So if I go to the next step here, then I can, these artifact parameters control the way the query runs, right? So when you write an artifact, when you are creating one, then you can surface a lot of these parameters for the UI, for the user through the UI to be able to control the way your VQL runs. So, for in this case, this specific case, I have a checkbox here to say, also download the scheduled task files, which are XML files. So Velociraptor will parse them out, tell you what scheduled task is going to run. And if you check this checkbox, it will also give you the original XML files in case you wanted them. And normally we don't, but in case you do. And then in the next step, we can specify resources. And that goes back to the point that we discussed before about like, what are we doing on this endpoint? Are we going to slam it with a lot? And depending on the artifact, like if I want to Yara scan the whole drive, that might take a really long time, and I want to control this a little bit. So you can see these are the limits that I impose on this particular collection. I can go fast or slow, right? So if I'm doing like a Yara scan, I might want to go slow because it doesn't matter and I don't want to slam the machine. I can specify a time limit for the collection and how much data to actually bring back, in terms of how many rows to bring back and how much to upload, how much data is it going to upload. So these are the defaults, right? So normally I don't touch them and I can review that if I want. But anyway, once I click the launch, it goes off and does it. And it's going to go off to that endpoint. And you can see down here that as it's doing it, the stats are updating, so it's finished, right? So we've got 196 scheduled tasks that it's collected, and in this case, because we're uploading the scheduled task XML files, it's also uploading them. So we've got some bytes that it grabs. I can export all that stuff. I can prepare a download and then export it as a zip file if I wanted to. But a lot of the time we don't need to do that. And then over here we've got how long it took, 1.8 seconds, when it started. These are just the normal things. Now because we uploaded the XML files, and we can go also. So you've seen before, we can make a zip file with all of it as a package, or we can just grab one. If we just wanted to get one, we could just grab it straight off the server here. But these are the results that come back, and you can see that because it's a query, then results are a table. So they come back as just a table, like columns and rows. And that the shape of that table, so the columns are described by the query itself. So it's different all the time, right? You can change it. You can in this case, we've got the full path of the task, the command, arguments, and so on, right? And then we have this notebook here. So with notebook, we can actually interactively investigate, post-process the data using VQL. And I would say that would be like maybe intermediate to advanced feature, but you can basically start to where commands matches cmd.exe or something like that, right? Like you can then sort of filter it or sort it or whatever, so to see like only the interesting stuff, right? So that's basically VQL for post processing. And you can use that as a notebook to post-process the data and collect things. So, I mean, I don't want to get into too much detail here, but just to give you an idea of how this works. Now, the next cool thing about it is that I could, for example, I've noticed just now that when I collect the task, the scheduled task, it doesn't give me the timestamp on the modification time on the XML file currently, right? Because I don't know, it's just been written not to do that. So this is the power of VQL, because it's all just queries, and I can go ahead and change things, right? So I can just tweak the current artifact a little bit, so I can see whether you can get a little bit more data to be able to do some interesting stuff. So in this case, for instance, like maybe I wanted to know when the scheduled task was created, but that current artifact doesn't tell me that. Well, that's okay. I can just change it. So I'm going to go to that artifact, and you can see that's the task scheduler artifact. So I'm going to go to this screen here, and this is our artifact, viewing kind of screen, right? Where we can see over here, there's all these artifacts we can search. So I'm going to search for the task scheduler, and this is our current artifact, the one that we ran before. And you can see it doesn't really give us back the time. And this is sort of like an intermediate, feature level, intermediate user kind of thing, where I'm going to take an existing VQL. I might not need to totally understand how this works, but I can change it to just give me extra data, right? So what I'm going to do is I'm going to click this.
Wait, don't be giving away all my secrets now, Mike. How many times have I said, I don't completely understand this, but I think if I just change this one thing, I can make it do what I want.
Right, exactly, right? Yeah, so in this case, I'm just gonna add the M time, so the modified time, and I'm just gonna just add an extra column to the M time. M time. Just going to add an extra column to the query. And of course, normally you would test it and make sure it's correct and all this sort of stuff, of course. But, it's not that hard. You can eventually you can figure that out and get, used to basically changing the query. So I'm just taking that existing artifact and I'm customizing it. You see it adds the word custom because it's customized. And I can add some data or just tweak it in some way, right? When I save it, then it creates this custom artifact. So now if I go back and I'm like, okay, I want you to collect, my custom version of my task schedule. So like here, that's the custom one. So that's the one with the extra, extra column and time, right? That I just added. And so now if I just launch it, I can just, I showed you all the steps before, but I don't need to to go through every step. I just, once I'm happy, I can just launch it. So it's really literally a one-click thing. And this time I'm not uploading the tasks, so that, I'm just getting the results. And so now I'm getting an extra, extra time, right? So now I can say, oh, okay, cool. Now I've got the time of modification of this, task. Let's go to the notebook and let's have a look. And maybe we can do a timeline. So I'm just going to make this full screen so I can see it a little bit better. And what I'm going to do here is I want to build a timeline. And so the first thing that I'm going to do is maybe I'm going to reshuffle this table. So I'm going to put the time first. The time goes in the first column. And then the command, so that's the thing that's going to run from the task, right? Command is going to be the second thing, and maybe the arguments. And I'm also going to put in the full path, which is the path of the actual task, the scheduled task, right? So I know what task I'm talking about. Remove the limit. So what this doing is it's running a query over the results that I've collected to sort of, post-process them and massage them and put them in a different form. So you can see that I've changed the order of the columns, and I've got the time first, and I've got commands, and now I'll be like, hey, that's really cool. Now I want to do a timeline because I want to see like how are these things, related. So I just click this thing on any table. I can add it to a timeline, and so I can see the events from every table like together. So I'm gonna create like tasks, create a new timeline, and I'm gonna call it task. This is it's gonna be a very simple timeline with just one thing in it, but just to give you an idea. So when I add that to the timeline, it creates a new timeline, and now I'm just going to view that timeline, and this is how we are seeing essentially all the events on a timeline. Now, if we had other things in here, like maybe prefetch executions or other things, then they would be, together in the same, table. And so those events will be, intermixed, and I'll be able to see, how they relate with time. So, so this one basically allows me to, to basically go through and do essentially a timeline, right? So this is kind of an idea, just to give you a bit of an idea of the kind of post-processing that we can do on the data. So we can collect the data from the endpoint, and as it's a query, it's just returning back a whole bunch of rows, and then we can post-process them and post-filter them. And you've seen how we can take an existing artifact and we can say, hey, we just need to tweak that a little bit and add another thing. So just to give you an idea, here is our docs. Velociraptor.app, which is our documentation page. And we have this thing called the Artifact Exchange here, which is a community resource for exchanging artifacts. So you can see here, everybody can submit, artifacts that just queries that they think are useful for whatever reason. And essentially, we can search on them here. So you can search for like, have you got something for, there's a lot of nightmare, Hive nightmare, print nightmare, all of these ones, right? And so you can click on those ones and it tells you a little bit about it. And this is community contributed content, right? So I can have a look at that and, just copy and paste that into the editor like I showed you before. But actually, let me just get out of the full screen thing. I can just automatically import all of the things from the Artifact Exchange. So, like this print nightmare, I can just go and run this exchange. So this is a server artifact. So the artifact's actually being collected on the server. And this particular server artifact is, it just basically imports the entire, artifact exchange into Velociraptor. So it just takes like one couple of clicks, and I'm actually able to now see all of these nightmare, print nightmare. These are all from the exchange, right? It just got imported now. So it means that I can, at the tips of my fingerprint, of my fingers, I have access now to all of these community provided content that, anyone, including you, can share on the Artifact Exchange. So you can see these are queries that are, doing some more sophisticated stuff that comes built in. How much time do I have? There's just so many features that we could, really dive in.
All right, one more feature, Mike. One more feature.
Okay, one more. So we can do a thing called a hunt. And a hunt is basically a way of running that analysis over all of our machines. And currently we have 201 machines in this test system. So before, you've seen me collecting the task schedule from one endpoint, and that was cool. But let's say that I wanted to do it from all of my endpoints, right? So I'm going to create this thing called a hunt task scheduler. This is just an example. I can, match by labels and operating systems and things like that, so to be more targeted. But in this case, I'm just going to get it from everywhere. Let me just do my custom one, the one that I just created. So the one with the extra thing. And I can configure it if I needed to, specify resources as before. And now I'm going to launch it. This is called a hunt. So a hunt is when I collect automatically from a large number of machines, right? All at once. So when you create it, it's in the pause state, and we can, kick it off. And you'll see that it will start to schedule these collections on all the endpoints. And then as those endpoints are coming back, you'll see they'll be finished, right? The number increases. And, this number could be 10,000, and it will just go and do it, right? And then you see I don't know how long it took, the time I was talking with you, I've got 200 machines in task schedule. So the scalability here is, I don't really know any other tool that can do that. It's really unprecedented. As soon as I click that, go hunt for this, then I do that. So now you can see that I can write my VQL to say, hey, why don't you look for this registry key, or look for this specific thing, or look through the event logs for a specific host name, username, whatever, and then tell me whether you have on that endpoint this indicator, whatever it is. So this is really a way for us to rapidly triage thousands of machines in minutes, right? And it's a really different approach, rather than collecting a whole bunch of data, which is your traditional forensics kind of approach of like, let's grab the MFT, let's grab all this thing. Then what I'm going to do is I'm going to do that analysis on the endpoint itself and just get back that, hit. Did I get a hit? Then I'm going to pivot into that machine and look more closely, right? So I can do that at scale and really quickly. So yeah, that's a really quite a useful feature. So I haven't actually had time to really kind of explain maybe like a third of Velociraptor in this very quick time, because we have lots more things like event detection, real life Sysmon integration, all this kind of stuff. So I encourage you guys and viewers to check out our documentation page. And we've just closed the Velociraptor contributor competition, so we'll see what comes out of that. That's really cool. We've had some really cool submissions as well. But take a look at the documentation page, and also we have a training. So the full training course that is on here. I mean, it's quite long, but it has a lot of information in here and a lot of documentation. And also jump on the Discord. There's a link to our Discord, and introduce yourself and say hi or just lurk. We'd love to have you join our community.
Outstanding. Any final questions?
No.
Looks fun.
Absolutely.
Yeah, it is really fun. The thing that's really exciting for me is because it's such a flexible system, because it's fully controlled by VQL, then I love to sit back and see what people make of it. And some people think of some amazing use cases that I had never thought of, that really kind of push the envelope on what's possible, and open it up to many more use cases. So it's very people are really creative when they when they get excited by this.
It's awesome stuff. I just have 5 questions left for each of you. It's the same
Okay.
5 questions for each of you, and I'll start with one person, then I'll switch to the other. It sounds really confusing, but there's no right or wrong answer. So, Wes, I'll start with you first. 3 words to describe yourself.
Sorry, put on the spot. I'll say probably perfectionist, quiet, and noodles.
Mike, 3 words to describe yourself. Noodles.
Oh, digital paleontologist. I think that's 2, right? Yeah. So yeah, I'm just having a lot of fun doing this DFIR work and talking with people, and I think it's fun.
Exuberant. Mike, if you were a serial killer, what would be your weapon of choice?
A serial killer. My weapon of choice. Puppies, I think. Let's go with puppies.
Wes, if you were a serial killer, what would be your weapon of choice?
I have to say marshmallows.
Mike, if you had to write, I'm sorry, Wes, if you had to write a book about yourself, what would the title be?
This guy is weird.
Mike, if you wrote a book about yourself, what would the title be?
Oh, a book about myself.
That's a great title, actually.
Or puppies.
Well, yeah. The digital paleontologist. Let's go with that.
Mike, what is your favorite hacker movie?
Hacker movie. Well, see, a lot of the hacker movies, they don't really have a reflection of real world, right? It's kind of ridiculous a lot of the time. But yeah, I don't know. Maybe War Games, because I'm that old.
Wes, favorite hacker movie?
No. Maybe Sneakers.
Wes, choose 2 celebrities to be your parents.
Alive, dead, fictional, or otherwise.
Stereo.
Let's see. Loretta Lynn and Gary Busey.
Oh my God.
I like the Gary Busey is a crazy mofo. Have you heard stories about Gary Busey? Someone was talking
I was seeing a lot of
on
stuff.
some podcast about Gary Busey and how like he hangs out in his house in just like his bathrobe and invites like people over and then like shoots a shotgun like off the back deck and shit.
It's like your house on a Tuesday, Paul.
Yeah, pretty much.
Exactly. I was going to say, wait, I think you're confusing Gary Busey with you.
Perhaps.
Did I say the right name?
Mike, choose 2 celebrities to be your parents.
Oh, why just 2? There's so many.
Well, you know, we are kind of time constrained. I mean, if you want to say 3, I'll allow 3, but 3 max.
Well, you know, we could do the Beatles. That's 4, right?
I'll allow that.
Yep.
Does that include?
So you'd get like a Paul, Ringo, John,
Yoko Ono,
Chimera, hosted by Yoko Ono.
Yoko Ono, that's the one.
She could be the brood mother,
right?
Of
She's
this
the nanny. She's the nanny.
Heinous beast.
Mike and Wes, thank you so much for appearing on Paul's Security Weekly.
Thank you guys.
Thank you very much.
Make sure you check out Velociraptor. Coming up next, Larry and I and the crew will talk about Enzyme Wi-Fi intrusion detection system. Stick around.